Today we're going to talk about complex fractions. And for us, that's going to mean fractional numerators and fractional denominators. It could also mean decimal numerators and decimal denominators. But since we're dealing with rational expressions, we're going to see a lot of fractions. So if my complex fraction is just numbers, okay, then what I'm going to do is just read this as a division bar. So the giant one between the numerator and the denominator, I will read as division. So we have -3/5 divided by 3/7. So multiplied by 7/3. And then I can do my simplifying and end up with -7/5. And even when they throw in some monomials, it's still going to work in a very similar fashion. I'm going to write this as 2x to the third y over 5x squared divided by, so multiplied by, 7y over 10xy squared. Let's see, my 2 and my 10, right? They're all monomials, so I'm not in any jeopardy here. I have y times y, which is y squared. I have x squared times x, which is x cubed. So I end up with 1 times 7, 7, over 5 times 5, 25. 7 over 25. Alrighty. Here I have a binomial numerator. And actually, what I have are two fractions. Think about this as m over 1. Here I have one fraction, so that's all right. But what I've created here is the need to subtract first before I can visualize this as division. So when you get a complex fraction, sometimes you get three problems all in one because maybe you have to do some work to make the numerator into a single fraction, and maybe you have to do some work to make the denominator into a single fraction, and then you can actually read the giant vinculum as divide. In this case, my denominator is already a single fraction, but my numerator is two fractions. So common denominator would be m, so I need to multiply top and bottom of this second fraction by m. So I'm going to get 3 minus m squared over m, right? Divided by, so multiplied by 4 over 3 minus m squared. Okay, this is a binomial, and this is a binomial. And you might say, well, you didn't do any factoring, but they're identical, so I'm just going to cancel them and say that my final answer is 4 over m. Uh-oh. I have 3 fractions in my numerator, and I have 3 fractions in my denominator. So I need to make this into 1 fraction in my numerator and 1 fraction in my denominator. I think the common denominator is x squared. So this fraction needs x squared. This fraction just needs x times x, and that fraction doesn't need anything. While I'm at it, the common denominator in the denominator is also x squared. So this fraction needs x squared. This fraction needs x over x. So I think I'm going to do this in a couple of steps. So my numerator is 4x squared minus 11x minus 3. My denominator is 2x squared minus x minus 15. right. So, okay. So now what I have is 4x squared minus 11x minus 3 over my common denominator, which was x squared, multiplied by the common denominator for the bottom, which was also x squared, happy accident, over 2x squared minus x minus 15. Okay, monomial, right? Monomial. Goodbye to you. I wonder if factoring this will get me some canceling. Let's see, negative 12 to make negative 11. Yeah. Okay, so 4x squared minus 12x plus x minus 3, right? Because that would be, yep. So by grouping, I get 4x times x minus 3. These have only one in common, x minus 3. So I have this numerator is x minus 3 times 4x plus 1. And this is now a 1 because I've already canceled that. Let's see, what have I got here? I've got negative 30. Yeah, so I get 2x squared minus 6x plus 5x minus 15. 2x times x minus 3 plus 5 times x minus 3. So this denominator is x minus 3 times 2x plus 5. X minus 3, right? I'm multiplying. So my final answer is 4x plus 1 over 2x plus 5. Okay, let's see. Two fractions in the numerator, two fractions in the denominator. I'm going to need, let's put parentheses around our binomials to make sure I don't make a mistake here. Okay, so in the numerator, this fraction needs x minus 1. And this fraction needs x plus 3. So the numerator looks like 5x minus 5 minus x minus 3, which looks like 4x minus 8 over x plus 3 x minus 1. And the denominator, this fraction needs x plus 3. And this fraction needs x plus 2. So I have 2x plus 6 plus 3x. Oh, 3x plus 6. I thought that was a 12. Okay, oh, big fraction bar, big fraction bar. So I have 5x plus 12, right? 2x, 3x, 5x, 6, 12 over my common denominator, which was x plus 2, x plus 3. Alrighty, so now I have one fraction in the numerator, one fraction in the denominator. I'm ready to go. Oh, I have to be able to see the problem to go. So I have 4x minus 8 over x plus 3, x minus 1, multiplied by x plus 2, x plus 3 over 5x plus 12. And again, binomials, I should put them in a parenthesis. All right, what do I have? I've got x plus 3. I've got x plus 3. This would be 4 times x minus 2. That's not going to cancel anything. And this is nothing. So I think I'm stuck. I have 4x minus 8, x plus 2, x minus 1, 5x plus 12. I've done all I can. There's no more I can do.